In this video, we want to use a graph to determine the domain, the range, the x and y intercept or intercepts, and the function value at particular values of x. And so you can see the graph we're given over here on the right-hand side in blue, and we want to use that to figure out, first of all, what our domain is. So keep in mind your domain are going to be your x values, and the way you figure out your domain is you say, how far to the left do we go versus how far to the right do we go, and you put those answers in interval notation. So for this particular function, you can see the function goes off the grid on the left-hand side, and that little arrow that I'm pointing to with a red arrow, it indicates that the graph is going to continue going to the left and downward. So for the domain, we're interested in how far to the left do we go. Well, we keep going to the left forever. And if that's going to be your answer, then your first value, I guess, in your interval notation is going to be negative infinity, because it continues going to the left forever. So now domain is how far to the left versus how far to the right. And so to see how far to the right we go, we can go to the rightmost point on our blue curve that we have drawn on here. And the x value that's associated with that point is 7. And notice that that 7 is filled in. It's a solid dot. And so we're going to go from negative infinity all the way to our rightmost point, which is 7. And we're going to include 7 in that because it is a solid dot. So that's why we're going to put a bracket around the 7. And so that's going to be our domain. How far to the left, negative infinity, to how far to the right, all the way to x equals 7. Now looking at our range, that's going to be in terms of our y values. And so for the y values, we're thinking how far down versus how far up. So again, this little arrow on the left-hand side, it indicates that we're going to continue going in the same pattern forever, meaning we're going to the left but also down forever. So if we're going down forever, then our first value in the interval notation of the range is going to be from negative infinity. And we're going to go all the way to whatever our highest value, or how far up do we go with this particular function. Now we have a certain issue with this exact example. We have a gap. If you're thinking about your y values, we have this gap right here where there's a removed point. And so what we need to do is we need to worry about this section first of all, from negative infinity all the way to the highest value, and then we'll add that point in separately because that's just one blip. It's just one exact point or one y value. So when we say how high do we go, we're talking about this continuous piece of the function right here, and we'll worry about the point later. So the highest y value that we have on that continuous, quote-unquote, not continuous as a mathematic, but that piece of the graph, we go to a y value of 4. And that happens all along this horizontal stretch right here. So our range is negative infinity all the way to 4. And we do attain that value of 4, so we're going to put a bracket around it. Now we're going to do a symbol for union, that means also including, and now we're going to make notation for that point of 7 right up here because that is a y value and we need to include it. So negative infinity to 4, also including the set containing the point 7. So we do the brackets around that because it's just a set of individual values. So you want to keep that in mind. So that's going to be our range. Now let's talk about our x-intercepts. These are going to be all the places where we run into the x-axis. And the only place it looks like we run into the x-axis on this graph is right here. Let me mark it in red. Looks like we run into the x-axis at x equals negative 8. And it looks like that point is negative 8, 0. So our x-intercept in this case is going to be negative 8, 0. And our y-intercept is going to happen right here. I'll mark it in green at the point 0, 4. So we're just going to say 0, 4. Now, if the graph you're looking at is the graph of a function, you'll only ever have one y-intercept, because if it had more than one y-intercept, that would violate the vertical line test, therefore making it not a function. So that's something to keep in mind. So now let's go ahead and look at the next part of the question. The next part of the question is asking us to find the function value at, whoops, some of the function disappeared there, hold on. We want to find the function value at x equals 0 and x equals 5. So at x equals 0, let's do that one first. Keep in mind, if it's a value inside of the function, in other words, the f of 0, that's going to be an x value. So you go to your x value of 0, and then you go up or down until you run into the graph. In this case, we'll go up. We run into the graph at the y value of 4. So the f of 0 is going to be 4. That's the associated y value. The f of 5, we're going to do the same thing. We'll go to our x value of 5, and then we go up or down until we run into the graph. Well, of course, we're going to go up again. But notice we're going to skip right past this hole, because that's a hole in the graph, so there's no value there. And we're going to skip all the way to that point, which has a y value of 7. And so our answer in this case is 7, because remember that hole, it's like there's nothing there. So when we go up or down, we would just go straight through it. And that's it.